Hello, this is a demo of my graphics engine called Hotline, which is written in Rust. The code is available on GitHub, Crates.io as well. I'm just going to do a demonstration of some of the features of it. This is to accompany a blog post I've written which has a bit more detail about things I've done in the code and how it works. So this is just to kind of demonstrate visually what it's capable of doing. So the main focus of it is that it's a live coding tool, so it has hot reloading, and it's got this client which can load plugins which can be loaded dynamically, and you can edit shaders and render graphs and render pipelines and all of that stuff in data files and have it all propagate through and keep the client running so you can kind of iterate fairly quickly. So I'll show some features of kind of things that you can do with it very briefly as an overview, and then I might just go into a bit of coding just so you can kind of get an idea of what it can do. I've got a bit of UI here using ImGui. These are actually separate windows with ImGui viewports that you can sort of drag and move around. This isn't really an editor, and my intention is that it's not really an editor. The editor is your code, your text editor, and so on, and this is just sort of relaying some information. I actually prefer that one on this side. Information. I've got some things like I can change to different demos. That's just a basic cube. Here's some more cubes, and there's some tests and stuff there which I'll show a little bit later. And then there's just information fed back. This is still, very much a work in progress, but I'm fairly happy with how it's been working. So first things first, I'll just do a quick demo of this is some code. This is Rust code. It's stored in a plugin and it's loaded dynamically. If I say comment out this, it's building now. You can see down here I'm running with this through the Visual Studio terminal, so I can get some output in there. The builds can take a little while. That's one took 11 seconds. What I've actually done there is to reduce the number of primitives that are being rendered. So I've been working on creating these primitives, and now if I recomment those back in, let's see how long the build time is. It's usually about 5 seconds to 6 seconds, in that kind of ballpark when it's quick. I mean, that was 8. It's taken a little while. It might be because I'm recording as well. It is variable, and I've done some investigation into this, but I haven't really got to the bottom of it yet of how to improve it. So at the moment there is a little bit of latency with editing code and seeing changes reflected, but also if you were to make those changes in code and then reload the application, it's still going to take that amount of time to build. So it's still faster. The code reloading is certainly something that I want to actually improve. So what I've actually just been working on is I've been making this chamfer box. Is still a little bit messy, and with the code editing I was going to maybe just continue on working on that, but before I go into those kind of details, I'll show a little bit more of the features. I've bumped the text size up here a bit larger than I usually like it. Data's in another repository at the moment for some various reasons which you can read about in the blog post, but I have shaders. Let's just go into a regular old HLSL shader. So this is a useful thing. If I edit this, I mean, the shader changes come through pretty rapidly. This is a gradient of the U coordinate in the UVs. I also have the V coordinate, and I've been using that for debugging purposes to try and get nice smooth UVs, and reset that back. So that feels super responsive, and it's building quite a few shaders. It checks which only bits have changed, and it only reloads things that are in use. So it tries to mitigate the cost of shader compilation Obviously, that's a big topic these days, but for what I'm working on, it's pretty quick. So going beyond shaders, there's a lot more cool stuff you can do. So I have these things called pmfx. There's a GitHub repo called pmfx shader, which is mine, that has more info about this, and I've used it in older projects. I'm kind of just bringing it a bit up to date with more modern style graphics engines. But things you can do is, like, you can specify render graphs here with dependencies. If I want to say remove this meshes step, I could just comment it out. This syntax of the config is called JSN or JSON. It's also something I've worked on. It's like a kind of customized JSON format, but you can have comments, you don't need quotes. It has inheritance, which is quite useful, especially for these render configs. So that's why I've got that. People say I'm reinventing the wheel all the time, and I am, but I actually like it, so that's it, basically. I could edit those and make changes, so I can change the render graph, or I could extend the render graph. I got some pipelines here. I can also modify those as well. These pipelines actually reference things that are in another file, the parent one. So we can specify depth stencil states, raster states. We can create textures and views, and we can edit all of this as well. So say if I do depth test less and I disable depth test, basically, you can see that they change, and then it changes back. I can modify the raster state. If I change this depth bias on the wireframe, the wireframe's now kind of offset slightly differently. If I change the cull mode to front, for example, then the cull mode's changing. And this all feels really responsive. I can do stuff like change the textures. So this is called the main dock, this window. This is an ImGUI dock. There is a slight performance issue with the resize at times, but I need to dig into, but it doesn't really matter for now. But I can scale these. These are basically saying the ratio size of this render target is linked to the main dock, and I can reduce that to 0.5, 0.25. It's becoming a little bit noisy, but you know, obviously if you want to have downsample, multipass kind of post-processing techniques, that doesn't need a comma. So I can specify things like that. Can also change the number of samples. This might be a little bit harder to tell on a video, but that's basically disabling anti-aliasing. And down here, in reference to the render graph before, you have, this is enumerating kind of like the update and the render and then the command queue. It has these resolve barriers in there. Now the resolve is not happening at the moment because I've got 8. I've not got samples. But if I bump it back to 8, then the resolves are inserted automatically so we can sample from textures, and that's the whole point of the render graph. Can kind of build up dependencies and do barriers automatically for you, and concurrently dispatch or concurrently make draw calls or compute, for instance. So that's demonstrating. Even interestingly, I can even do like change this to say the main color to R32F, and that's changing the render target color, which is quite cool. And that all gets rebuilt. All the pipelines have to be associated with that format of render target. So here you can see that we reload the views, recreate views, and pipelines have to be sometimes rebuilt depending on the format of the render targets. Then views is a bit more of a kind of a custom concept, but essentially what a view is, it's like a render pass, but we have more information associated with it. We have a you know, we give it our frame buffers like a render target and a depth stencil with a clear color. So I can modify the clear color in here. This is of the main thing. That goes nicely like a normal maps. Put that back. I could change the depth buffer, so if I clear the depth buffer to 0, then nothing renders because we're always failing the depth test. And yeah, we can supply a camera. So this is the main camera. I mean, the main view, it's actually a little bit sluggish. I guess it's because I'm recording at the same time. I've not really done this before, so I might cut this video short actually. But there is sort of example demonstration of rebuilding pipelines. It feels alright now actually. It's weird, it seems to be coming and going in waves, a bit of performance dips. So yeah, at the moment these are the things you can edit. I still have yet to get around to adding blend state and those things. They're kind of implemented in the shader system, but they need to be propagated through into the engine. But yeah, I've been using this tool essentially to build these primitives, make sure I get nice smooth normals on them. There's some issues here at the moment of like the capsule, it's not quite welded between the top sphere and the cylinder sides, so I've just been working on those. Might be worth demonstrating that. I've been working on trying to make this robust and stable, so there's quite a lot of error handling and I've got some tests. So these things are called demos. I've got a demo of primitives, a demo of just draw index. This is drawing index, many draw index with push constants, which I want to be able to essentially set how many draw calls and get some profiling statistics. Next I'll move on to adding like draw index instance, draw index instance indirect, and so forth, those kind of things. So you can have a missing demo, it handles it, it just doesn't render anything, it just gives you an empty kind of grid. If you've got missing systems, it'll show you in here missing systems. Systems are like, this is Bevy's ECS by the way, so the Bevy ECS system, there's setup, update and render systems, and they're in here. And then any issues, so if there's a completely missing render graph, we're not actually doing anything there. If there's a missing view, we can't do it. Missing view, it doesn't feed back the info here. Propagating the errors and stuff has been a little bit tricky to get the information where you want it to be, because it's sometimes if something fails, subsequent things are also going to fail. So that one isn't very clear, although you get the warning down there. If we have a missing pipeline, this is an annoying bug in GUI. Scroll wheel. So in the missing view, there's an error that it could not find a pipeline for format missing. So missing is the pipeline it's looking for, which is missing because it's a test. And then this is the format. So like I said before, any pipeline created in data, so for example these pipelines, these don't really care about if they're into an MSAA render target or not. They don't really care what the format of the render target is. Essentially when we want to use that pipeline, when we build a view, it will generate a compatible pipeline for the format of the render targets that it's going into. So that one, it couldn't find that. It should always find them because it should build them for you when it needs a view, but if you've mistyped something or it's missing in data, then you want to know that. Here's a failing pipeline, it's the same error basically. A pipeline can fail to compile. That is if you have a weird mismatch kind of vertex and pixel shader where the vertex shader doesn't export the things that the pixel shader requires. Missing camera, again, it shows us that there's a missing camera called missing that is part of the meshes path. And that, oh no, we're back. That just took a little while longer. I'm not used to that. So back in here, this one's actually supposed to be a billboard. I've just been working on. And then this one is a chamfer box. So maybe I'll show a little bit more coding of how I was doing this. I've got the sides, they need improving with the UVs and the normals, tangents and that, but the geometry I've kind of worked that out. And maybe I could show interactively by editing code how I can how I did that. So here's a bit of an insight into the program structure. This is the main, I'll close everything, the main repository from GitHub. We have the source, which is the main source code. Then we have kind of these AV, GFX, and OS, which are abstraction APIs. So OS has Win32 and GFX has D3D12. This is only Windows only at the moment. And then you've got like GFX API, which is like a platform agnostic graphics API with, you know, all of the stuff in there. And then I've got plugins, which are the things I'm working in. There's an ECS plugin, which is kind of the core Bev ECS, which can actually it sets up the systems and builds a Bev ECS schedule. And then ECS demos is kind of functions that get imported by the ECS plugin, and they can add stuff like this where I'm adding primitives and rendering meshes. Now some of this functionality I'm working on, and I might absorb that back into the main code base, but for the time being I'm working in plugins, and the plugins are what can be dynamically reloaded. So another thing I did was I've got this file called dev, and this has all of these create sphere vertices and so on, and some of this code is duplicated back in the main engine. I just moved it into a plugin so I could work on them interactively. So at the moment, these are the bits that, well, really, I'm at the moment, let's take out the corner, because I'm not, oh. So again, the slightly slow load time, let's see what it's at now, 6.47. That's kind of roughly in the ballpark. It's usually about 5. That is not ideal, but it's also not that bad. And in time I could imagine, because it has to reload the scene to kind of set things up again if you modify the code, which affects the setup. So I can imagine sometimes that's going to be the bottleneck, depending on what you're working on or what I'm working on. So maybe I show how this worked. I think I've got a neat way of solving these edges. So if I take out the edges, actually, to begin with, let's see. Oops. Bit annoying. Errors. I'll take out these edges so I can sort of show them one at a time. Building 5.99. Oh, that's actually crashed. It's because my code is relying on So interestingly, this can happen. You can crash. I've got these command line one stop. Okay, that's still there. I need to rebuild. So obviously you can hit a panic or something, and then the program terminates. Like I said, I've been trying to handle it, but then you can get straight back in there fairly quickly. And even if I was to do something like, say, if I bring the camera down here and I safely exit, and I don't have to rebuild again. It's rebuilt quickly, and the camera, the state's serialized. So even if you have to go back to build the entire thing, it's fairly quick. And sometimes I might have to make changes inside the client or inside the main library, which aren't hot reloaded, and then I can easily get back into it. So I've put quite a lot of effort in there to actually being able to work efficiently, whether it's hot reloading or not. Let's just have a look at, say, I'm just going to comment out adding these, maybe I'll just do line by line. Builds failed. No. I'm just going to not add the indices of the sides. Right, okay, so this is what I started with, a cube. There's already a cube over there, so it's easy to just take the cube faces and inset them slightly. And then the problem is to try and join these two edges. Now the way I did that was interpolating between two different points, or creating an interpolation between, say, this edge in here. Obviously that's going to be a diagonal line, but you can also create one which comes out to here, and then if you lerp between this one and this one, then that gives you the corner. And the way I did that was using a lerp, which, let's see if we can just demonstrate this. I'm going to take that out. Okay, that's much better. So these are my original lerps, and then this gets clamped in an axis. But if I remove these and I just grab this, these ones are called LV0, LV1, LV2, LV3. So that gives you these kind of like, you know, obviously diagonal edges, but it's been split or tessellated, kind of. And then how to achieve the other one, got this cool function Chebyshev normalize. I actually need to move this into my maths library. Part of the fun or things I've been focusing on here is having nice like maths functions. So I've got like lerps, which are generic, which you can just use like that, or these vectory quick constructors. You know, you've got normalize, sin, cos, atan. These are all kind of like, it feels like shader language basically, and I was able to get through all of that with generics. I wrote a blog about that a while ago, but essentially this is very similar to, I've got a C++ maths library which is very similar, so it actually makes porting between the two code bases quite easy. So actually quite a lot of these primitives came from my C++ engine. I didn't have UVs on them before. Here's some more sin causes, atans. There's you know, quite a lot of stuff in there. I've got like loads of intersection tests, overlaps, different geometric shapes and things. And part of that's just for, you know, I like having a nice sort of lightweight maths well, not lightweight, but ergonomic maths library. I'm not too focused on the performance of that, so it's not SIMD. It's just scalar maths, but vectors, matrices, and everything. So this Chebyshev normalize actually came from my. I've got some shader code which was using this, and I'm going to move that into the maths library. But it's quite magical what it does if you haven't seen it before. It's like if you think about a normalization as normalizes to a sphere, Chebyshev normalization normalizes to a cube. And so that creates these for you, which is pretty nice actually, you know. So that creates those, and then like I say, if you lerp between the two, the Chebyshev normalized position and the linearly interpolated position, then you get this nice curve. The UVs aren't ideal here, so they look really noisy, and the normals are like kind of stripy. That's just because I'm just basically cloning a vertex and changing its position, because that's all I've worked on so far. So then getting back into, let's stick the corner back in, which so I've done one corner hard-coded. That's how I originally started this. I did the join edge and then made it into a closure. I have to say I really like the closures in Rust. They're quite simple. I always sort of forget the syntax of C++. It's a little bit more fiddly, whereas the Rust one's quite nice. So I implemented a hard-coded version, which was just joining originally. I think this was my first one I did. The front face to the right face with hard-coded indices, and then I figured out how to generalize it. These muts and clones will go when I actually properly work out the normals and tangents and UVs. But I'm doing the same process here for joining the corners. This is a hard-coded one where I know my corners are vertex 2, 10, and 18. The original vertices from the cube mesh are hard-coded, so I know that's what they are. And then it's kind of joining the loops. So if I put them back in, so that's back in now. No, it hasn't saved. So if I put it back in, I've got it working roughly, the geometry, but this kind of this edge, it might be hard to see because of the normals, the UV. It's not smooth, and the problem is I'm projecting the corner pieces to a sphere, but then also welding the edges so they join. And I think basically it might be a little bit complicated, but if I lerp between, say, here and here for this one, then that might work. But also it's kind of hard to know. I can show an example of how it's sort of working. If I change the radius of the sphere that gets projected into, it creates actually quite an interesting effect. So they're welded and the edges are kind of flat, and then it's got that inside, which is quite a nice effect, you know. The corner there, that the topology of that actually looks all right, whereas like if I pull it out to its a correct size of radius, it has a little bump to it. So that was something I was looking at last night and was sort of thinking, how am I gonna resolve this? I mean, it doesn't help that my UVs are so messed up. Maybe I'll go to I don't know, have a look at the shader and then take off the checkerboard. I mean, that reduces the noise a lot actually. And there you can see that little dip. So the question is really, it's like, how should I work this out, and how should I interpolate? I mean, it's welded, and it's not so much of a problem. Like the mesh is watertight. It's just that it's not smooth. It's a little kink, and yeah, see there, you can kind of see this. This is undesirable. This little dip there. So like my thinking was, I'm not really sure what to do, and this is why I sort of like, if I did a demo on a stream, I tend to spend a lot of time just sitting still and thinking, and it's not that enjoyable. Maybe maybe I could think about how to generalize this to the rest of the corners, because currently I'm at a bit of a loss. I mean, a way to do it would be, I mean, it is a quarter sphere. It should be a quarter sphere. So, yeah, I feel conscious now that I'm just sort of sat here thinking maybe that's something to do for another time. I tell you what, maybe I'll start looking at, let's try and sort out the normals, because the normals should be fairly easy to derive from this. There's also an additional edge in each of these strips, so it adds a quad strip for each, and they're not joined. So this is a separate quad and this is a separate quad. This in between vertex is not shared. So that's the sort of thing I've been working on. To be honest, I think I might leave it there because it's just you know, the video intention was just a quick summary really of where I'm up to. I think now I've got to the point where I'm trying to do something. My brain has given up. So I mean, maybe in future I'd get more confidence to do these kind of things, and if people are interested in that, then let me know. Check out the blog. If you found this video, then you probably found that as well. If you give me a follow on Twitter or anything like that, then you know, you could ask me questions or check out the repository. Let me know what you think, or don't. Anyway, see you later.